This video is about finding the cross product of 3x3 vectors. But in order to understand that, the first thing we're going to do is to talk about the determinant of a 2x2 matrix. So if we have a 2x2 matrix, 3, 4, 2, 1, in order to find the determinant, you would multiply the values going from top left down and subtract the values that are multiplied when you go from the top right down. So in this case, the determinant is 3 minus 8, or negative 5. Problem 2, we have 2 times 3, which is 6, minus 5, or 1 times negative 5. So 6 minus negative 5, or 6 plus 5. So the determinant of the second one is 11. The third one, negative 16 minus 0. So we get negative 16. So that's how you find determinants of 2x2 matrices. Now the cross product is if you have two vectors, a1, b1, c1, and a2, b2, c2, then the cross product is b1, c2 minus c1, b2, I, minus a1, c2 minus c1, a2, j, plus a1, b2 minus b1, a2, k, which of course looks impossible to memorize or remember. So we don't ask you to remember it, we just ask you to use 2x2 determinants in order to figure it out. So this can actually be found by writing the determinant of a 3x3 matrix. And the determinant of a 3x3 matrix shows up by finding 3 separate determinants of 2x2 matrices, and then either adding or subtracting. So let's say we want to find the determinant of this 3x3 matrix. What we do is we put the vector u here, the vector v here. It doesn't really matter which order you have them. And then you have I, j, k up on top. So remember that I, j, k are just the x direction, y direction, and z directions. So in order to find the determinant of this, what you would do is, if you want to find the I determinant, you eliminate everything in the same row and column as I, and then you take the determinant of whatever's left. So notice that we're going to find the determinant of this 2x2 matrix, and then multiply it by the vector I. Then we do the same thing for j. So we eliminate everything that's in the same row and column as j, and then we have this matrix that we find the determinant of and multiply it by j. Notice that this one is a minus sign, so that's the only thing that you kind of have to remember with that. And then we do the same thing with k. We eliminate everything in the same row and column as k. We take this 2x2 matrix and we multiply the determinant of that matrix by the vector k. And when you do that, that's where you get b1, c2 minus c1, b2 times the vector I, minus a1, c2 minus c1, a2 times the vector j, and a1, b2 minus b1, a2 times the vector k. So that's basically how you get it. And the vector that results from this cross product is perpendicular, which we also know is called orthogonal or normal, to both u and v. So let's do an example. if we have the vector u, which is 4, 7, -1, and the vector v, which is -2, 5, 6, find the cross product. So we're going to write this as a 3 by 3 matrix determinant, ijk, then the vector u is here, and the vector v is here. So if I want to do I take everything out that is in the same row and column as I, and then I have 7, -1, 5, 6. So then I do the determinant of this, 42 minus -5, and the determinant gives me 47. So I have 47I. Then I do the same thing with j, so I eliminate all the green and the entire top row. I have 4, -1, -2, 6. I take the determinant, which is 24 minus 2, so I get 22j. Then I do the same thing with k. I eliminate row and column, and then I have 4, 7, 2, -5. I do the diagonal stuff, 20 minus -14, which is 34k. So this is my vector, which I can also write like this. And we're going to confirm that this is orthogonal to both u and v. So first what we're going to do is do the dot product of u and v, and we see that we get 21. So u and v are not orthogonal. That's something that's not required. When we do this, we can just take any two vectors. You can pick any two vectors that you want, take a cross product. These two vectors are not orthogonal. But the new vector w is orthogonal, so this new one is orthogonal to both u and v. So notice that the dot product in both cases ended up being 0. Because that's the case, this new vector, 47, -22, 34, is perpendicular to this one and perpendicular to this one.